Page 325, number 45, reads, 2012 Olympics gold medalist Mariana Pajon races on a BMX bike with 10-inch radius wheels when she is traveling at a speed of 24 feet per second. How many revolutions per minute are her wheels spinning? Now, this problem has two parts to it. The first is going from a linear velocity to an angular velocity, and the second one is doing the correct unit conversions. Now, what you want to make sure that you're reading carefully is that her linear speed is given in feet per second, and we want revolutions per minute. So we're going to have to convert from seconds to minutes, first of all. And also, our first conversion, which gives us our angular speed, will be in radians. So we'll then have to convert the radians to revolutions. So we'll go through that process here. So let's first get our angular speed. So remember that linear speed v is equal to our angular speed times the radius of the circular object. So that means that our angular speed is equal to the velocity divided by r. So when we do that, then we're going to take our linear velocity, which is 24 feet per second, and I'm writing it this way for the conversions. And the first thing I'm going to do is multiply that times my conversion factor, which is 60 seconds per minute, so that now I'm in minutes, so that the seconds units will cancel. And then what I'm going to do is I'm then going to multiply that times, or divide that, by my radius, but I want it to go from feet to, I have to change my radius, which is in inches, to feet. So over here on the side, I'm first going to do that conversion. So I'm going to take 10 inches, and I'm going to change that from inches to feet, knowing that 1 foot is 12 inches. And when I do that, I get this as a decimal of 0.83 feet. So now what I'm going to do is then divide this by 0.83 feet. So I'll write it this way. So you can see that the feet now cancel. And this leaves me with a measurement of 1,734.94, and this is in radians per minute. And our original problem wants revolutions. So now what I have to do is I have to use the conversion factor, that 1 revolution is 2 pi radians. It's 1 trip around the circle, which is 2 pi. So what I'm going to do is I'm going to take my 1734.94 radians per minute, and I'm going to multiply that by my latest conversion factor, which is 1 revolution is 2 pi radians. And when I do that, I get a final answer of 276.12 revolutions per minute.